Good afternoon, everybody. My name is Sunowi Pirama. I come from Indonesia, and now I'm studying master degree here. And currently, I work in the real-time three-dimensional eye movements tracking and visualization using dual cameras acquisition. And this work actually will be implemented in the hospital, so we need to track the movement of the eye for the patient or the human in order to know whether the patient has the disease or not in his eye. And in our research, we use the head-mounted camera, as you see here. So we install the camera in the low-cost goggle here, and then the user can wear the goggle, whether they can move their head freely. Now, we would like to introduce you into the how the eye move. Actually, the eye move in the three-dimensional, which are in the horizontal, the vertical movements, and also in the torsional. As we see here in this picture, we can see that the eye can move in the horizontal direction, in the vertical, and also in the torsional. And right now, there are a lot of eye movements tracking method, such as here is the first is the electrooculography, which is they put the sensor around the eye, and also we have the scleral search coil. So they install the coil on the contact lens inside the eye, and then they connect the contact lens to the electromagnetic frames, and they can measure directly in the eye movement in 3D. However, some researchers found that this method is not comfortable for some users because they have to wear the corneal lens or the contact lens, so that they want to find another method that more comfortable than previous method. So they try to paint the eye, and also they use the image processing to detect the movement of the eye. Firstly, they paint the eye, but they found also that they need complicated procedure to detect the eye. So currently the well-known method, the popular method, is tracking the iris striation of the eye. And in this method, we want to develop the low-cost or inexpensive eye tracking using this is the method, 3D coordinates extraction, and also the lens anti-distortion we use to improve the accuracy of our eye tracking. And finally, we can perform 3D visualization based on the real-time eye movement tracking results. And this is our materials. Actually, we have the goggle here. We have the goggle, and also we have the system built using the Borland C Builder and also OpenCV. OpenCV is open source library to do image processing, and for the visualization we can do using the OpenGL. And for the pupil tracking, directly there are a lot of methods, but we use several methods to do some thresholding here and then remove the noise. And finally, we use the center of mass algorithm to find the center of the pupil. This method will be used to detect the horizontal and vertical movements of the eye. To detect the torsional movement, we use the template matching algorithm. So we cut the iris striation or the iris pattern of the eye, and then use that pattern to detect the torsional movement of the eye. And to improve the accuracy of the system, we use 3D coordinate extraction and also lens anti-distortion, because in cheap camera we found that there is a distortion in the camera, so we have to remove the distortion in order to provide more accurate results. And this is the visualization. So we use the OpenGL to create the 3D model of the eye, and then based on the real-time results, we transform the results into the visualization. And for our experiment, we use the open field and also closed field. For the first experiment, we want to measure the voluntary eye movements, which is we stimulate the user to gaze or to see the visual stimulus, and then we track the movement of the eye. And this is some results. Whether in this research we can prove that the user can use this method or use these tools to detect the voluntary eye movements. And for the next experiment, we also measure the involuntary eye movements. As we said before, that in some patients they have several diseases, and the most well-known or the most popular disease is vertigo. So we can use our method to detect the vertigo, which was already done in Zina Karin Viraj Hospital, Pathum Thani, Thailand. So we has one patient, female patient, 56 years old, and then we use the eye tracking goggle to detect the vertigo. And actually we can find that the vertigo occurs around 10 until 15 seconds and then gone. I think this is just an overview of our research. Thank you very much.